Good afternoon, everyone. Welcome to our third webinar on collaborative robotics. We've got Stephanie and Jesse from Doosan for this part. We've also got Industrial Automation Supply here co-hosting, and so I will let them get the presentation started.
Hey, thanks so much, Mike. So welcome everybody to the final installment of our Collaborative Robotics webinar series covering cobots in manufacturing. This is part 3, looking ahead, trends and innovations in collaborative robotics. I'm Stephanie Calloway with Doosan Robotics, and I'm delighted to have everybody join us today. So thank you very much. This is the last in our 3-part series over collaborative robots. I am joined today by Jesse Hidalgo, one of our very talented application engineers. In today's session, we're going to look ahead at the trends shaping the collaborative robotics industry and innovations that are making automation more accessible than ever. Throughout this series, we've explored the role of collaborative robots across different industries and how companies are successfully implementing them. In this final session, we're going to focus on where the market is headed and how new technologies like AI and software innovations are driving cobot adoption to new heights. But before we dive in, I'd like to extend our sincere gratitude to the Manufacturers Association of Maine for providing this platform to share our insights with you guys. I'd also like to mention that if you're looking for a local resource for everything cobots, Industrial Automation Supply in Portland is a great place to start. They're our regional distributor, and they can help you with everything, selecting the right cobot, finding the right system integrator, providing local support. They can handle it all. So with that, let's take a look. Here's what we're going to be covering today. So first, we'll do a quick recap of our last session. Then we'll dive into where the collaborative robotic market is headed over the next 10 years, followed by an introduction to Doosan's Dart Store, which is making it easier than ever to integrate cobots into real-world applications. And then Jesse's going to take us through key trends and emerging technologies shaping the industry before we wrap up with a Q&A session. So if you do have any questions during the presentation, there's a chat box over to the side. Please be sure to drop your questions in there or stick around after we're done if you like, and we'll be happy to answer anything that we can for you. So, in part 2, we explored real-world applications of collaborative robots, from manufacturing and logistics to food and beverage and pharmaceuticals. We highlighted some success stories that demonstrated how businesses are improving efficiency and safety with cobots. And today, we're going to take that a step further by looking at where the market is headed and how new innovations are shaping the future of automation. Just a reminder that if you missed parts 1 or 2, or 1 and 2, you can find those on the Manufacturers Association of Maine YouTube channel. I'm sure it's links posted on their website, or you can just Google search that. So now let's dive in and talk about where the market is going. So the collaborative robot market is experiencing rapid growth. Industry reports right now forecast that the market, which is currently valued at $2.1 billion, will grow to nearly $14 billion by 2034. We're seeing this increased demand reflecting a compound annual growth rate of 19%. So why are we seeing such growth in the technology and the demand? Well, first, the adoption of cobots is really being driven by labor shortages. Also, cost reductions in automation and technological advancements are making robots more capable and user-friendly. So we're also seeing increased demand across industries, and as cobots become more intelligent and versatile, their role in automation is only going to expand. The substantial growth that we're seeing is driven by a few factors. Many industries right now are experiencing workforce shortages. I'm sure many of you can attest to that as well. It makes automation an attractive solution to maintain productivity. Also, cobots offer a more affordable entry point into automation, particularly for small and medium-sized enterprises, otherwise known as SMEs, due to their lower initial investment and operational costs compared to traditional industrial robots. So not near as expensive to implement a cobot. Also, the training barrier is much lower. Also, ongoing improvements in cobot technology have enhanced the capabilities of the technology, making them more versatile and user-friendly. So this evolution allows these SMEs to implement automation without the need for extensive programming expertise. For these small to medium-sized manufacturers, the expanding cobot market presents significant opportunities. By integrating cobots, these SMEs can increase efficiency and consistency in production processes, enabling them to compete more effectively with larger enterprises. So, much more enhanced competitiveness. Also, flexibility and scalability. Cobots can easily be reprogrammed and adapted for various tasks, providing these SMEs with the agility to respond to changing market demands without substantial reconfiguration costs. So, a lot of the solutions that we're seeing, again, for example, are on casters. So you could roll it from one solution to one line to the next line, making it very flexible. And then lastly, and perhaps most importantly, worker safety. Cobots are designed to work alongside human workers safely, taking over repetitive or hazardous tasks and reducing the risk of workplace injuries. So, as cobots become more intelligent and versatile, their role in automation is only going to continue to expand. We're just now finding out what these can really be used for. And it offers these small to medium sized enterprises a practical pathway to modernize operations and drive growth in an increasingly competitive market. One of the biggest barriers to automation is the complexity of deploying robots in real world applications. So, in order to address this, Doosan has come up with the Dark Store. This is just an example to show you, not just Doosan, but everybody is kind of moving towards this democratization of cobot applications. It's an online marketplace of pre built software solutions that allows businesses to access and implement cobot applications with ease. So, think of it like an app store, but for cobots. Whether you need a palletizing solution, a machine tending workflow, or a vision system, Dartstore is going to have plug and play software that reduces programming time and makes automation a lot more accessible to companies of all sizes. And now I'm going to turn it over to Jesse so he can discuss some key trends and emerging applications.
Thanks for that, Stephanie. So, in the previous series, Matt discussed the automation ecosystems, where cobots belong, peripherals, and led into some real life cobot applications. And he reviewed those from easy to hard, and then he also discussed some solutions. So, that plus part one served as the building blocks, but there are some barriers, as Stephanie said, that still remain that still make it a little bit difficult to use robots or cobots in general. So on the screen, we can see some common applications for cobots now. But today, we'll be talking about technologies that are starting to open up the breadth of applications where you can apply a cobot in the future. So one of the most common solution-based cobot products are palletizers. Matt might have shown you guys some videos in the last presentation. And he also reviewed modules, which resemble apps on your phone in terms of their operation and intuitive use. The apps he reviewed were to simplify integration of peripherals such as grippers or a safety scanner. Instead of having to worry about integration, it brings one more piece of technology to the plug-and-play state. So taking that same concept a step further, there's a trend starting, as Stephanie said, building on the concept of having a store directly for robots, for developers to create apps that can target an entire process. The major difference between the application-based approach and the solution-based approach is you're not restricted to the layout and hardware that a solution provider gives you. In this case, the verification, for example, of reach, speed, and the layout is all done on the cloud. You have the freedom to make your layout as complex or as simple as you want. Using an application to tackle a problem means a developer cannot be sure you represented your environment correctly in simulation, though. So when we consider using an application for our process, we have to be mindful of external hardware that we may need to remain safe. In this video, we can see how workpiece dimensions are entered and a pallet pattern is generated. The hardware layout is also fed as an input, and then a simulation is created in the cloud. And if you think that the simulation is acceptable, you now have a program that can be generated for your robot, and you're ready to go. In the future, we expect solution providers and developers to tackle other processes with an app-based approach. So let's briefly take a look at some of the industries that are starting to be explored for opportunities to deploy cobot solutions. Personal care. Here, we can think of things such as a massage or a physical therapy session. Existing automation is fixed and usually performs single tasks. The potential benefits are a massage therapist or a physical therapist could serve more patients at the same time. For example, if they're going to guide you through a range of motion, then they could tell the cobot how to do that, and then walk away and attend someone else, and so on and so on. With current technology, performing that task is still a bit difficult. Systems that exist in this space can't fully adapt to the different shapes of the human body. And while we have technology like force and compliance control for cobots and can adjust robot motion easily using things like hand guiding, it doesn't 100% solve the problem. So how do we fully adjust the robot's actions to handle the bodies of different shapes and sizes? We'll talk about that a little bit more when we talk about some of the emerging technologies. So for the construction industry, this is an area where there are still many humans doing tasks that could be performed in a safer manner. Tasks like fastening, bricklaying, and applying drywall are some of the applications that are starting to be tackled by cobots. Having cobots support construction workers can offload ergonomically challenging and unsafe tasks away from humans, and with supervision, allow robots to perform them. A good example of this is fastening or drilling anchors at high elevations or overhead. Third, for cleaning, there are already some cobots being used to do things like washing down equipment in industrial facilities. But there are also companies starting to explore using them to clean commercial buildings, doing things such as cleaning toilets and sanitizing. A common challenge that all these industries face is that to create a solution, you have to be able to adapt for various environments. Not all construction sites are the same, and no two cleaning sites are the same. A technology that we can see being used here is a mobile manipulator. Matt may have shown you guys some videos of this in the part 2 of the series. Lastly, most cobots, or just low-end robots on the market, don't have a high enough IP rating that allows them to be in a dusty or wet environment. It could also be thought of as how weatherproof your equipment is. For perspective, your home camera, which is mounted outside, usually has an IP rating of about 65. For cobot manufacturers, we are starting to see demand from customers to do IP67 or higher. So the higher the number is, the more weather resistant it is. I expect it to be standard for cobots to have higher IP ratings so that they can be used for more outdoor applications. So from a hardware and software point of view, researchers are working to make robots faster and stronger, not just from a capability perspective, but also when it is applied. What do I mean by this? Cars, for example, are designed to go 140 miles per hour. But due to our infrastructure and safety, we find ourselves going 60, maybe 80 miles per hour if you're lucky enough to live in Texas. But for better, most cobots in the market don't have a high enough IP rating. So that allows them to be in a dusty or wet environment. But this could also be thought of, I'm sorry, not that. I already reviewed that. But when we talk about cobots, there are usually speeds for when a human is in the workspace and in collaborative mode versus a full speed industrial mode. So this is drawing on the correlation to the vehicle. So even though the cobot can go, let's say, 600 or 500 millimeters per second when a human is in the workspace, due to its hardware and software limitations, it can't achieve that because it can't accelerate to the speed fast enough. So advances in material sciences could yield lighter materials, which could contribute to a faster acceleration with the same motors, and being able to set a faster speed when a human enters the work zone, because you're going to be able to move slightly faster since you have lower weight, and you'll still be able to apply the same force that's acceptable. Now, from a software perspective, path planning and how the robot moves from point A to point B and how it tells each joint to accelerate and the velocity it's able to reach is currently based on fixed algorithms. So researchers are also working on optimizing motion using tools like AI, which we'll touch briefly on later. For the stronger portion, 20 to 25 kilogram cobots started reaching the market around 2019. And as of the start of 2024, there are now 30 kilogram cobots. So it took about a decade for cobots to go commercially from 6 kilograms to 20 to 25 kilograms, and from 25 kilograms to 30 kilograms commercially, it took another 5 years. I believe the future of cobot payloads will continue to trend upwards towards the 50 kilogram range. There are some applications when it comes to material handling that require just another couple of kilos to be able to do with present technology. But there are some limitations. A heavier cobot would mean that you would require more power. If you recall from the previous series, most cobots only require 120 volts, so you have a power limitation. One way around that is to reduce the total weight of the robot. Again, we're depending on advances in material science, or to require more power for your cobot, such as having to use 240 volts. But the challenge to do both of these things is doing them and maintaining reliability within your robot, both from the hardware perspective and from a safety perspective. So from a software perspective, we can see increased payload range updates for cobots on the market, but usually you have to sacrifice speed, acceleration, or reach to be able to add an additional 1 or 2 kilos. But as robots get stronger and material science advancements occur, another thing that must improve are the end-of-arm tooling. So let's segue into some of the challenges posed there. As cobots get faster and stronger, end-of-arm tooling must also evolve. An example of this happening within the last year is after the release of 30-kilogram robots, within a year, an electric vacuum gripper that can handle 30-kilogram cobot applications also reached the commercial market. But currently, there are many different end-of-arm tools which are process-specific, and many times still require customization. So the challenge that we face today is being able to perform more tasks with the same end-of-arm tooling, being able to have higher dexterity, handle irregular objects, and also increasing safety. So higher dexterity via hand. The gripper on the left-hand side has 24 joints and is available in electric and pneumatic versions. It is able to more closely mimic human hand movements and approach applications the same way a human does. I believe we may start to see this because customers want to reduce the amount of tooling that they have in their facilities, and they want to avoid having to redesign end-of-arm tooling or adding middle processes or redesigning their packaging to be able to handle it with robots. This particular company has also shown that they can teleoperate a robot using a glove, which leads to motion of the hand that's mounted on the on the flange of the robot, and then that motion can be recorded and replayed. So it's another interesting approach to program how a robot can be programmed. As for handling irregular objects, we're starting to see this being approached with the use of soft grippers. In part 2, we talked about claw style and vacuum grippers. But what about these tentacle-inspired grippers that are useful? Even if you're not lifting the same shape every time and don't particularly care about its orientation, you may find yourself asking, why can't I use a soft gripper? They are adaptable to be able to pick up different objects and are usually pneumatically operated. For end users, this means another potential gripper to consider if you're handling various parts in the same system. Thirdly, for increased safety. In a previous series, we talked about safety scanners and how they allow your robot to go from moving at a very fast industrial speed to going to a collaborative mode when a human comes into the work zone. But what about applications where they're still concerned about jamming or pinch points or the tool being unsafe for a worker's hand? So safety is an ever-increasing bar that we cannot ignore. And here on the right-hand side, we can see one of the later innovations in end-of-arm tooling, which is an end-of-arm safeguard. So this goes on the flange of the robot, and basically it works the same way as a safety scanner or a light curtain. If you break the barrier, which is represented by the red light, which you can't see in real life, but you could set the curtain, the robot comes to a safe stop, and then it starts back up when the hand is removed from the area. Yep. So next, I'll be talking about AI. What changes can it bring about? So in my mind, when I hear about AI, I'm eager about what it means for robotics. But also, I think about the movie iRobot. So if any of you have watched iRobot, you know that some of the robots turn red and then they start attacking humans. But fortunately for us, robots aren't sentient yet. So they aren't able to make conscious decisions yet. But AI definitely will have incremental improvements to how robots make decisions and also support humans during integration and post-installation. So let's talk about what is AI before we go into the 3 different areas where AI will make a difference for robotics. So artificial intelligence. Everyone has been talking about it lately, as if though it could be a solution to all our problems. Here we see a bunch of screws on a table and AI as a hammer. Yeah, it's a bit true, but there's also real impacts of AI for robotics. So for reference, the AI definition that I like is AI refers to the development of computer systems that can perform tasks that would normally require human intelligence. These tasks include learning, reasoning, problem solving, perception, and language understanding. In the news, we've heard a lot of talk about improvements to GPUs. Why is that? Well, one way to improve AI models is to feed them more data. Now you need to process all this data. So to process all this data, you need better GPUs, and better GPUs lead to better AI models. And this all means improvements in the field of robotics. But if any of you have ever seen a robot controller, you may know that most of them don't have GPUs. They only have a CPU. So what does this mean for industrial robots? Well, I'd like to divide it up into three different aspects, both simulation, chatbots, and then machine vision. So currently, a lot of time is spent validating robotic processes in simulation and creating copies of our physical world just to validate things like reach or speed or cycle time. This is especially common pre-sales and multi-robot systems, or for prior to factory acceptance testing, and these are both very time-consuming tasks. With collaborative robots, this isn't as time-consuming since barriers to programming and accessibility are reduced due to their inherent design. But what if you can improve the way you program and determine how many robots you'll need for a system that you're creating a proposal for in a shorter period of time? So our challenge here is, how do we use simulation to minimize the time needed around a robot and be able to plan for unexpected scenarios and also have an accurate model of the robot's environment? A couple of examples of simulation that's enabled by AI is improvements to motion planning. So as I said earlier, motion planning now is pretty fixed, but we're seeing researchers are starting to generate real-time collision-free motions, and they're using just a single fixed camera above the system that's streaming data, and it could be trained on millions of data points and millions of point cloud generations. And then this could potentially lead to end users being able to improve takt times of installations that are already on their floor, or of their installations pre-install. And it could also mean reduced programming time. AI is also being used to generate realistic images of your work environment. In practice, this means larger data sets to train vision systems. For example, instead of having to create random layout of parts in a bin, AI can generate realistic images that correspond to real-world physics, and then this could all be fed in to create a larger data set for your AI model to be trained on, reducing the time that you spend in the physical world trying to create images for the model. So currently, the challenge that we have is in the space of robotics is that you must rely on manuals, experienced, or knowledgeable people for help. The challenge is that there's a lack of technical human resources, and we also need to reduce the time to be able to respond when we have a question. We don't have enough time to sort through documentation. The goal is for AI to be able to minimize the response time when a problem arises during installation or troubleshooting. So I believe chatbots for things like service and preventative maintenance will occur first. A chatbot similar to those pop-ups that you get at the bottom right corner of your website screen may be able to help you solve problems or at least point you to a reference documents page. The reason I believe this to be true is all service issues and troubleshooting problems are now being logged in databases. So if you are able to feed this as a data set to be able to train an AI model, over time it'll improve and be able to give you some feedback or at least point you to a reference document instead of you having to search through a bunch of reference documents for the right place to find the answer. As for programming, chatbots are starting to become mainstream. These may be implemented through the teach pendant or voice commands. The latter relies on how much improvement we have to our natural language processing. But recently, we've seen these in humanoid companies using a form of a chatbot where our operator is giving the humanoid prompts to pick up objects. In the background, they're converting your voice to text and then feeding that into commands to the humanoid. But that ability of picking up objects in those demos that we see relies on the next thing that AI is going to help us with, which is machine vision. So currently, machine vision, 2D and 3D cameras allow for robots to handle quality control and part position. We could think about processes where part position cannot be guaranteed, and fast-moving lines are too fast for human quality control. So the challenge is vision projects can sometimes be costly and time-consuming integration that requires experts. So let's see how AI could affect quality. So AI and quality control means a more reliable system for pass-fail. So validation and shorter time to set up new parts, and it allows operators to avoid having to set up too many rule-based programming. So the benefits are, as the system processes more data, it also gets more accurate since it's adding images to its database. And so you'll be able to reduce the amount of defective parts and anomalies that come up later on down your line. When we think about picking boxes from a pallet, for example, this is in regards to part positioning in the point cloud and the image on the bottom right. The easiest application would be to pick from a pallet that contains a single type of box. But what if the box is flat? Instead of being flat, it's on its edge, or if there's different sizes, or what if you have a mix between boxes and bags, for example, like Amazon type packaging? Well, you need to be able to generate a reliable pick point, and to tell the robot not just a pick point, but also a reliable approach on how to approach it to be able to grip it. So companies are starting to use AI to generate more reliable pick points in depalletization environments. And researchers are working on a way for a robot to interpret items the same way that humans do, so that we can then give them commands, working back towards the chatbot future possibility. And then it is able to, on the bottom right, we see it is able to classify, detect, and then segment an object in its environment. And then it'll also give you a position. This is already happening. So now let's look at a couple of examples where vision and AI are already taking place. So in this example, this company is called Plus One, and they provide vision systems for depalletization in warehouses. They're using a very inexpensive camera, which on the left-hand side we can see is mounted overhead, and they're training models to generate accurate pick data based on they're analyzing point clouds here. And here we can see it picking from a pallet that has the same style box in different orientations, but they're also capable of handling dissimilar products in both different shapes, colors, sizes, weights, and dimensions. Interestingly, though, on the topic of collaboration and collaborative robots, this company recommends their human-in-the-loop approach. So where you don't rely solely on the system and AI or the model that you trained, but you can also they give you the option to call on a human operator for help if the robot is stuck or if the model doesn't have a high enough certainty rate to go to do a pick. And then a worker who's working remotely analyzes the situation, identifies a pick point or identifies what the robot should do next, and then that is fed into the data set. So over time, the model is also improving. Could you go on to the next slide, please? So this company is the most interesting because they combine two of the technologies that are kind of bleeding edge. They're called Lab Zero, and they're using both the advancements in AI for machine vision and the advancements in AI for simulation, which we'll see in the next slide. So they just started publicizing, or they just went public with what their solution is in the last month. And they're making use of the most advanced simulation tools to perform vision training, improve decision making. They're doing physics-based learning using AI, and they're learning how to grip both rigid and soft body objects in simulation. And they're also doing real-time object and object manipulation in simulation before they launch their solution into the real world. So I recommend you check their website out. But on the next screen, here we can see a couple of AI-enabled tools, and these are all part of NVIDIA's Omniverse. And the tools that we see here are Isaac Sim and Isaac Lab, and they're using this to test for edge cases. So on the upper left corner, we just see a crate, and we can kind of see how they're, most companies out there are expecting, all the boxes to be stacked perfectly. Well, that's not real life, but on the upper right corner, we see a bunch of robots, and each one is trying to handle a green box. And if you look closely, every single green box is in a challenging orientation, or it's fallen, or they're trying to simulate what a fallen box would look like. So they're testing for edge cases and how to best approach the pick position for each of those boxes, and then implementing that into the real world. And lastly, on the bottom right, those are AI generated images that look very realistic, and they're generating, again, different configurations of boxes within a crate. and then they're feeding those AI generated images into the data set for which they're training their model. So instead of having to recreate all these different crate, or I guess how all the boxes are presented to the crate when it arrives to the system, or having to go to a bunch of different customer sites to look at different crate orientations, they could do it all in the simulation world. So the accuracy of the simulation allows them to trust the simulation results, and they're reducing how much time they're spending testing in real life. Lastly, I think the thing that ties everything together is many robot systems don't have the capability to connect directly to the internet. And even those newer robot controllers that do aren't connected to the internet because of cybersecurity fears. So the cybersecurity fears still outweigh the benefits that come from connecting the robot to the internet. But the challenge is, how do you make improvements on the fly, leveraging things like improved motion planning, using AI, instead of using fixed algorithms, and also make use of all this data that you can gather, right? So I believe in the future that many robots will be connected to the internet directly, and cloud services will be available directly from the robot manufacturer, which will allow the end user to be able to optimize their motion and shorten their cycle times. On-cloud analysis of data from the robot, potentially coupled with a video stream to give more accurate predictive maintenance recommendations. I believe that'll also be part of the service. And lastly, I believe that they'll provide fleet monitoring capabilities and improve remote support capabilities. So currently, if you try to remote support someone, you have to connect to their laptop, and there's a couple of steps in between. But I think all that may be reduced. So these benefits combined, I believe, may outweigh the perceived risk of cybersecurity threats, similar to how a cybersecurity attack on our laptops now wouldn't stop our companies from telling us that we need to have internet on our laptops. All these technologies will play a role in other applications as well. So in the videos that we saw, we see them for the packaging or logistics industry, but I'm eager to see which ones take off commercially and how they're applied to other applications.
Great. Thanks, Jesse. Thanks a lot for that. So if anyone has any questions for either Jesse or myself, there's a chat button up at the very top next to the people button where you can drop your questions in there and let us know. Or if you have a question you'd like to ask outside of this, our email addresses are our first and last names and @Doosan, or Mike can get you in touch with us to answer any questions that you may have, or also reach out to Industrial Automation Supply, and they can also help there. So it looks like we don't have any questions. So, oh wait, we do. Hold on. Who at IAS we talk about getting an estimate for seat. So John, that is going to be Mark Chapman at IAS, and I can drop his email address in the chat for you, or we can reach out as well. Great. And are there any other questions? Gotcha. All right. All right, there you go. So thank you everybody so
Oh,
much.
looks like there's one more
Oh,
that slid
we
in
do.
there. Comment on applications to 3D printing.
Yeah,
Jesse, you want to take that?
so there are some 3D printing applications for robots in general. I've seen them with cobots as well, where they mount the head to the end of the robot. But I guess it comes down to the level of accuracy that you need. So you might not be able to beat a 3D printer's accuracy with a cobot, but if you're printing something that doesn't require high accuracy, not just between cobot, but between cobot and robot, then you may be able to use a cobot to do 3D printing. And then most cobots and robot manufacturers in the market could accept the G code directly, so you don't have to worry about that. So whatever your slicer gives you, you should be able to just plug it into the robot as well.
Excellent.
And then the other
questions so
thing
far?
is I've also seen kind of the same kind of thought for machine tending for CNC machines. There's also some things where I've seen where there's certain 3D printer farms where they're tending their machines with cobots. But I think maybe that for the 3D printer, the ROI starts to make more sense if you could be if you could be on a linear rail with a cobot, or if you could be mobile. I don't know how long you would want a cobot to sit there when you have a 10-hour print, for example.
Any other questions? Okay. Well, thank you guys for participating in today's session. And for those of you that joined us for the entire three-part series, we really appreciate your attention and your interactiveness and the questions that you asked. And we are always happy to help share information about collaborative robots to anyone and everyone. So please feel free to reach out to us. We also appreciate the Manufacturers Association of Maine for this opportunity to engage with the community, and also to our partners at Industrial Automation Supply. So if you have any questions or need any assistance with cobot implementations or general questions or applications, please be sure to reach out to IAS based in Portland. We can also connect you with them. I did drop Mark's email in the chat there. Sorry, Mark, I just gave everybody your email address. So they're ready to support your automation needs. And we thank you guys so much for your attention and for joining us.
Yes, thank you, Doosan and IAS for hosting this series. It's been very good, and I think we'll be seeing more from them in the future. Everybody have a nice afternoon.